Can you imagine a world without time? In the eons before our existence, the universe was devoid of human-made measures. Time, as we understand it, did not exist. Then came the dawn of humanity, and with it, the dawn of timekeeping. Our ancient ancestors, in their profound wisdom and curiosity, looked to the skies for answers. The sun, moon, and stars became their celestial clocks, their rhythms echoing the passage of time. The changing positions of these celestial bodies, their cyclical patterns, and the seasons they brought forth, became the earliest markers of time. From the ancient Sumerians to the Mayans, civilizations across the globe observed these celestial cycles with awe and reverence. They meticulously recorded these patterns, etching them into stone and parchment, creating the first calendars to track the days, months, and years. But the celestial bodies weren't the only timekeepers. The rhythm of life itself, the cycle of sleep and wakefulness, the ebb and flow of tides, the emergence of buds in spring and their fall in autumn, all became natural metronomes, ticking away the seconds of our existence. The ancient Egyptians took this understanding a step further. They harnessed the sun's shadow, creating the sundial, our first true timekeeping device. This ingenious invention allowed them to divide the day into smaller segments, creating a system of measurement that would evolve into the hours, minutes, and seconds we know today. But timekeeping was more than just a scientific endeavor. It was deeply entwined with culture, religion, and philosophy. It shaped societies, dictated rituals, and influenced the course of history. And so, from observing the heavens and the cycles of nature, humanity embarked on a remarkable journey. A journey to understand, to measure, and to master time. Thus began humanity's journey of marking time, guided by the rhythm of days and the dance of the heavens. As centuries passed, our understanding of time took a revolutionary turn. Humanity, ever curious, began to question the very fabric of time. This curiosity ignited the flame of the scientific revolution, a period of great discovery and intellectual fervor that spanned from the 16th to the 18th century. In this era, two figures stand out for their monumental contributions to our understanding of time: Galileo Galilei and Sir Isaac Newton. Galileo, an Italian polymath, was one of the first to apply the principles of mathematics and physics to the study of time. He understood that time was not just a passive observer in our universe, but an active participant. His experiments with pendulums and inclined planes laid the foundation for the concept of time as a measurable quantity. Enter Sir Isaac Newton, an English physicist and mathematician. Newton took Galileo's insights and wove them into a grander tapestry. He proposed that time was an absolute entity, flowing evenly throughout the universe regardless of the observer. This was a radical departure from the cyclical concept of time that had dominated human thought for millennia. Newton also introduced the idea of a clockwork universe. Picture a grand cosmic clock, its gears turning in precise harmony. In this view, the universe operates like a giant machine, governed by laws of physics that dictate the movement of every particle, every planet, every galaxy. Time, in this model, was the unyielding tick-tock of this cosmic clock, a rhythmic heartbeat underlying the workings of the universe. With these revolutionary ideas, the perception of time was forever altered. Time was no longer just a cycle of day and night, of seasons and years. It was a fundamental dimension, a measurable quantity, an absolute framework within which the universe operated. The clockwork universe was born, and with it, a new understanding of time. This understanding has shaped our world in countless ways, from the way we navigate the seas to the way we explore the cosmos. And as we'll see, this is only the beginning of our journey through the Chronicles of time. But time, as it turned out, was not as constant as we believed. With these words, we enter the realm of Albert Einstein and his groundbreaking theory of relativity. This theory, which shook the scientific world in the early 20th century, introduced a new perspective on time, one that was fluid and malleable, rather than fixed and unchanging. Einstein's theory of relativity is a cornerstone of modern physics, and it holds that the laws of physics are the same for all non-accelerating observers. But more significantly for our exploration of time, it introduced the idea that time and space are interconnected in a four-dimensional space-time continuum. No longer could we consider time as an independent entity ticking away uniformly. Instead, it became a dimension that could be influenced and altered. This was a radical shift, a true revolution in our understanding of the universe. The concept of time as a fluid dimension, influenced by gravity and motion, is perhaps one of the most mind-bending aspects of Einstein's theory. According to this, time can dilate or contract depending on the strength of a gravitational field or the speed of motion. Imagine a clock at the top of a tall tower and another at ground level. According to Einstein's theory, the clock at the top, being farther from the gravitational source, would tick faster than the one at the bottom. Yes, you heard it right. Time would pass more quickly at the top of the tower than at the bottom. This is known as gravitational time dilation, and it has been confirmed by numerous experiments. So, where does this leave us? In a universe where time can bend and stretch. In a universe where time is not an absolute but a relative concept. In a universe where the flow of time depends on where you are and how fast you're moving. Einstein's relativity revealed a universe where time could bend and stretch, and in doing so it transformed our understanding of time, challenging us to rethink our place within the cosmos. In a world increasingly connected, we needed a common language of time. This need led us onto the path of standardizing time. As the world advanced, so did our methods of measuring time, each more precise than the last. From sundials to mechanical clocks, to the incredibly accurate atomic clocks we see today, our journey has been marked by continuous innovation. But what exactly is a second? This seemingly simple unit has undergone numerous definitions throughout history. Initially tied to the solar day, the second was redefined in the late 1950s, using the precise vibrations of the cesium-133 atom. This redefinition allowed for far greater accuracy, making it possible to keep time to within billionths of a second. Yet, even as we refined our measurement of time, a new challenge emerged. With the advent of global communication and travel, a universal time standard became increasingly important. This led to the creation of Coordinated Universal Time, or UTC. UTC, a compromise between solar time and atomic time, serves as the basis for civil time all around the world. It's not tied to any specific place, but instead, it's a time standard that everyone can refer to, no matter where they are. Through UTC, we've managed to synchronize our clocks and by extension our activities across the globe. This global time standard has had far-reaching implications, aiding everything from international business transactions to scientific research. It's become an invisible yet essential part of our interconnected world, enabling seamless coordination and cooperation across different time zones. So, while time may remain a complex and intriguing mystery, we've managed to harness its measurement to our collective advantage. Through the standardization of time and the creation of UTC, we've given ourselves a shared rhythm, a synchronized heartbeat. With UTC, the world found a shared rhythm, a synchronized heartbeat. Now, we stand at the edge of a tantalizing question: can we control time? This query takes us to the realm of speculative ideas and scientific theories. Time dilation, a concept born from Einstein's theory of relativity, suggests that time can be stretched or compressed based on the relative velocity of an observer. It's a mind-boggling notion, isn't it? Imagine if we could manipulate this effect at will, slowing down time to savor a precious moment, or fast-forwarding through the mundane. While such control remains firmly in the realm of science fiction for now, it speaks to the power of human imagination and our relentless pursuit of understanding. Our exploration of time, its mysteries and its potential, is a testament to our intellectual curiosity. As we continue to unravel the fabric of time, we may find answers to questions we have yet to even ask. The question remains open, a captivating mystery that continues to challenge our understanding. As we look to the future, the quest to understand time continues. The realm of quantum mechanics presents a fascinating frontier in this pursuit. Here, scientists delve into the minutiae of the universe, seeking to unravel how the smallest particles interact with time. Theories abound, from the existence of time crystals to the entanglement of quantum particles across temporal distances. The search for a unified theory also marches on. This elusive theory would reconcile the vast scales of general relativity with the tiny scales of quantum mechanics, possibly offering a new perspective on time itself. Future research into time promises to be a thrilling journey into the unknown. It may challenge our current perceptions, just as Galileo and Einstein once did, and potentially unlock new technologies and insights. In this relentless pursuit of understanding, we find ourselves in awe of the timeless quest for knowledge.